So this is a short video on, this is a specific type of U substitution that's involving powers of secant and tangent and sine and cosine, etc. So here's the first example where we have secant to the fourth times tangent to the fifth dx. And there's really two ways you can go with this. In this one, we're wanting u to be secant x, and then du would be equal to secant x tangent x. In this one, we're letting u equal tan x, and therefore du would be secant squared x dx. Right? So again, what I did was I took this and rewrote it in two different ways. So you can see clearly the two options here, because if I'm dealing with secant and tangent, I either want, if u is tangent, then I'm going to have secant squared as my derivative, and if u is secant, then I can have secant x tangent x dx, by the way, right? And so I pulled out, in this case, I pulled out the secant tangent, the du. So the yellow portion here, let me grab some yellow from up here. So you can see the yellow portion here matches the du down here. So we're just saying that this whole thing up here, the yellow would be du, and same way down here, the yellow would be du. So you can see what happens when we pull out that du. And it makes it easier to see that in this case, notice if the du is secant tangent, then my u is secant. That means I need to be able to change all of these tangents to secant. Over in this case, since tangent is, my u is tangent, my derivative is secant squared, that means I don't want any secants in the leftover stuff, right? Because I want a bunch of tangent stuff here, so it'll be kicking out that derivative. And here I want a bunch of secant stuff here, so it'll be kicking out the right derivative. Okay? So now, what happens is I got to change everything that's not the right thing. In this case, I would have to change all those tangents to secant. So notice I have a tangent to the fourth here. Could I change a tangent to the fourth to a secant? Yes, because a tangent to the fourth is equal to a tangent squared times the tangent squared, right? And I can change tangent squared into something involving secant. But notice over here, since I want my u's to be tangent, I want everything to be in tangent, and so I only have to change a secant squared into tangent. So this is going to be the easier substitution. The second one will be the easier substitution, because here I'm going to have to plug something in for tangent squared, plug it again for tangent squared, and then multiply it out, so it's going to be a lot bigger process. So I'm going to not do that one. I'm going to choose to do this one. So I'll move it over here and focus entirely on this. So if I have u equals tangent, that means my first move is to change, and I'm going to leave the yellow stuff over there, because that's what's going to be du when I'm done. So I'm going to take that secant squared and change it into tangent. Now remember that secant squared is, remember that secant squared is equal to 1 plus tangent squared. So that means I'm going to substitute this secant with 1 plus tangent. So I'm going to have in here 1 plus tangent squared times tangent to the fifth times secant squared x dx. Okay? So just to make it clear, abundantly clear, notice that green came from that secant because of this. Okay? And likewise, this blue, of course, is exactly that. That didn't change. And last but not least, the secant squared dx is that right there. So it's still the same integral. We've just changed some things. Now we're ready to make that u substitution. So I'm going to change this to, this is still going to be 1 plus, but since tangent is u, this is going to be u squared. That'll be u to the 5th. And this will be du. As you can see, that's exactly du. And there's nothing extra or nothing missing. This is exactly the right integral and matches up. So do a little distributive here. That'd be u to the 5th plus u to the 7th. And I really got to work on my handwriting. Du, and then we go ahead and integrate that or take the antiderivative, and we get 1/6 u to the 6th plus 1/8 u to the 8th plus c. And since u is tangent, we've got to bring that back in. So we have 1/6 tangent to the 6th power plus 1/8 tangent to the 8th power plus c. So just to show you that again, it's very, another type would be if I have the integral of sine to the 3rd theta times cosine to the, 6th theta, and that's d theta. So we know that the derivative of sine is cosine and the derivative of cosine is sine. So for my du, I want to either have a sine or cosine d theta, and then change everything else into the right u. So if I wanted u to be sine theta, then du would have to be cosine theta d theta. And that's a problem because if I pull one cosine out, I'm left with an odd number of cosines, which means I won't be able to change them. Because remember, I'm going to use that Pythagorean identity that says sine squared theta is equal to 1 minus cosine squared theta, or cosine squared theta is equal to 1 minus sine squared theta. So notice in both cases they have to be squared. So in this case, I want to use sine as my du, because there's an extra sign in there, and I could change the leftover signs into cosine. So that means that my u is going to be cosine theta. So then my next step is to change this to sine squared theta times cosine to the 6th theta times sine theta d theta. Again, I'm just pulling this out so you can see the u. The du, I mean, notice that's exactly what I want right there. So I can see it, and that means everything that's left needs to be turned into cosine. So, so go back here and grab the purple. So that means I'm going to rewrite this as 1 minus cosine squared times cosine to the 6th times sine theta d theta. And now I can replace cosine with u. So this can be integral of 1 minus u squared times u to the 6th times du, because that is the same as that. And that would be the integral of u to the 6th minus u to the 8th du, which would be 1/7. And I'm just going to substitute the sign in right now. I hope that you're okay with that, because u is sine theta, so that'd be 1/7 sine to the 7th power theta minus 1/8 sine to the 8th power theta plus c. So that's u substitution. A particular branch is the u substitution where it's focused on products of trig functions raised to power.